Hello, I'm an old guy and I do maths. Today we are looking at what some people might view as a fairly terrifying looking sine function. And what I want to do is I want to go through the elements of this and explain what each one of them does and to try and illustrate that effect on a graph. Okay, so let's just get things sorted out here. So our function is y equals 2 sine 2x minus pi on 3 plus 2. Now, each one of these things does something different. Our original function, just to remind people, would have been y equals the sine of x. And it would look very roughly like this. And when I say rough, that's a comment on my drawing ability. So it would go through its cycle in the space of 2 pi, that is its period. It would have a maximum value of 1 and a minimum value of -1, even though I've drawn that badly. And you'll of course notice that I have enlarged our scale here. That is in preparation for what's going to come by way of an explanation. But this is the basic standard sine graph. Right, returning to this. In textbooks you will see what we've got written here, written in a general form of y equals a sine n times x minus h plus k. Now I want to go through what each one of these things does. A affects the amplitude. In this case, because there's nothing written here, we assume that it's 1. Now the amplitude of a sine graph at 1 is this. It's got a maximum of 1 and a minimum of -1. The amplitude is the distance between here and here, or here and here. And distance is always positive because, well, get out a measuring tape and find negative 1 foot or -1 meter. It's very difficult. Okay, so that's the amplitude. This number in here, which you see here as 2, is the number that we use to calculate the period. And we calculate the period of a sine or a cosine function. So everything that you see here holds true for a cosine function, although I will do a separate video on that. This allows us to calculate the period. Now the period is the distance, as I've said before, between here and here. It is one full cycle of the function as graphed, getting from its starting point here back essentially to the same point. In this case, if the period is 2 pi on n, we would take this number and we would discover that the period is 2 pi on 2, which is simply pi. And while I'm at it, the amplitude here is 2, which means that instead of, just to come back to this drawing, instead of the distance between here and here being 1, it is in fact 2. So it would take this graph and stretch it away from the x-axis. Right, this value here, which I've given it a precise value, negative pi on 3 here, but in general terms it moves the graph to the left or the right. So what does that mean in practice? Well, it's as if we take the graph and we do that with it. We just pick it up and move it left or right. Now, you will have seen this with a whole pile of other graphs. If this is negative, it moves the graph in a positive direction. If it's positive, it moves the graph in a negative direction. So what has happened here is we're moving the graph pi on 3, which is 60 degrees, and that's measured along the x-axis. We're moving this pi on 3 in that direction because that's negative. Finally, we come to k. Now k moves the graph up or down. And again, those of you who've seen all the other functions and graphs that you see in high school, parabolas, cubics, whatever, will be familiar with this. So if the number is 2, what it's going to do is it's going to take this whole graph and move it up 2. So what I'm going to do next, having just noted that we move up 2 units, is I'm going to try and show you all of these incorporated into one graph and just talk about them as we go. So if you just give me one moment, I will write in this function 2 sine 2x minus pi on 3 plus 2, and we can go to work. Okay, so I guess the first thing to note, the easy thing to note, is that this graph is going to be moved up 2. So I'm just going to draw in a dotted line here, and this is what is called the median. It is the median value of the function. Here the median value of the function is 0 because there is many positives here as there are negatives here. What we're doing when we have something like this on the end of the function, it doesn't actually have to be on the end of the function, but this is the normal order in which we do things, it moves that median up 2. Now we also have a change in amplitude, which means that this thing is going to have an amplitude of 2. So the median's here, plus 2 minus 2, means that this graph is going to sit between 0 and 4 with a median value of 2. It's still positive. Everything's positive here, so we haven't flipped this. If you wanted to reflect this in the x-axis or anywhere else, you would put a negative in front of here. But I think that this is enough for one video. Okay, what else has happened? Well, we've got a change in the period. The period is now 1 pi. So what's going to happen is that this graph here will get squashed down into this space. So in the space of 2 pi, we'll actually go through two complete circuits of this. Okay. Anything else? Yes, this is going to be moved pi on 3, 60 degrees to the right. Okay, well, let's get drawing. So let's just find pi on 3 here. So here's pi. Pi on 2 will be here. Pi on 3 will be here. And I'll just add pi to that so that I've got an idea of where this will cycle through. You'll see what I'm talking about in a moment. And I need a halfway point there just so that I can draw this thing. Okay, now our starting point, or my starting point, is here, and I just need a little patience on your part. I'm going to draw this, I hope, correctly. No, that's what I need to do, sorry, that comes down here. This is not a great drawing, but this is what this looks like. Now I've incorporated a number of things in here. I have moved this pi on 3 to the right, and what will happen is that this graph will continue over to here. I'm not going to work out what this value is. It's possible to do that. It's not very difficult. I just want to get the general shape of this. Now, you'll notice that our amplitude is 2 and that our midpoint here is 2. So that incorporates that and that. We have moved this graph pi on 3 to the left, so to the right, sorry. So instead of starting at 0 here, we start at our median value here, which is pi. This distance here is pi on 3. And we have moved the whole thing up 2. Now, I'm going to try and repeat this. My drawing is so bad, and I apologize. It should come over a little bit further there. And we'll stop there at 2 pi. This is shocking, but I hope it does illustrate all of the changes and all of the features. So what has happened? Well, it's as if we've picked this thing up, moved it to the right. We have squashed up the period. We've halved the period. So essentially we get one period in the space of a single pi, and the same thing here, badly drawn. It has been moved to the right, so we have this tail here, and this point doesn't quite reach the median here. It's been moved up 2, and that is the resulting graph. It is very different looking to this, yet it retains the essential shape. It's been distended in this direction, it's been compressed in this direction, it's been picked up and moved to the right, and it has been raised by 2 units. That's a lot to take in, especially with my poor drawing, and I apologize for that. I will try and do better next time. Thank you very much for watching. There will be a similar video to this on cosines and tangents, so watch out for those. And if you found this useful, please subscribe, and I'll see you next time. Thanks. Bye.